Okay, here we're going to use differentials to find the maximum error. So I've got the radius of a sphere was measured and found to be 21 centimeters, so this is going to be my radius, with a possible error in measurement of at most 0.05 centimeters. So that's going to be my change in radius, dr. What is the maximum error in using this value of the radius to compute the volume of the sphere? So we're looking for the maximum area of the volume. We're looking for dV. So if we think about the volume of a sphere, which is 4/3 pi r cubed, and we're looking for dV, and we're given dr, then that tells me I need to find the derivative of this equation. So I've got derivative of v, which we'll call dv. And then if I bring the 3 in front, that would cancel the 3 and leave me with 4 pi. And then take 1 away, r squared, and then dr. So there's my derivative. And I was given an r, given a dr, looking for dv. So I plug in what I know. The change in volume will be 4 pi, and then I plug in 21 squared, and then plug in 0.05 for dr. And then here I would use a calculator. If we were on a test, it'd be a little easier numbers than this. But here I'm getting about 277 cubic centimeters because it's changed in volume. And so that is my maximum error for volume. So that's what it's asking for. But what if we wanted to know relative error? You can find relative error by taking your change in y divided by your y. So in this case, we're talking about volume. So it would be my change in volume over the volume. Change meaning dv over v. So I've got 277 for my change in volume. And then my actual volume, if I go ahead and plug 21 into this equation, into the original volume equation, I get 38,792. So I've got my dV divided by my V when you plug in a radius of 21, and I get 0.007. So that's my relative error, if they ask for that. You're used to, in science, being asked for your percent error, and that is your relative error times 100. So we've got our 0.007 times 100%, which is going to give you 0.7% for the percent error in this problem.